Assalamualaikum warahmatullahi ta'ala wabarakatuh. Bismillahirrahmanirrahim. And then today we continue with our lesson. And then today we need to understand the X-ray. And then understanding the wavelength, the minimum wavelength of the continuous spectrum. Okay, so actually we start from the COE. So COE is a conservation of energy. So we need to use the principle of conservation of energy. Okay, so and then before that we need to understand the circuit. Okay, here is the filament, and then filament is a cathode because cathode is connected to the negative terminal of the power supply, and here is a positive terminal of the power supply and connected to the anode. So here is the filament at the cathode, and at the anode we have the target atom. So in our target atom we use a tungsten metal. Okay, so we continue. So the first one, the filament is heated by the current flowing through it. So the filament here and is heated by the current flow through the filament, produce supply by the power supply here. Okay, so and then what happened? Number 2, the thermoionic emission occur. So the thermoionic emission occur at the filament. So and then what happened? The electron are emitted from the filament. Electron are emitted from the filament or cathode, then create a electron cloud. So here is the electron cloud. So when the filament heated by the power supplies, so the thermoionic emission happen, and then the electron are emitted from the filament, so they produce the electron cloud. Okay, so we continue. Electrons are attracted to the anode by the high potential difference across anode and cathode. High potential difference produce the electrical potential energy. So here is the potential difference between cathode and anode. So the potential difference produce the electrical potential energy. And then because the electrical potential energy, the electron accelerated to the anode. So we continue. Number 5, electrical potential energy of electron, or short name is a EPE, is equal to the QV, and then is converted to the kinetic energy of electron, half mv power of 2. Okay, so when the electron hit the target atom, kinetic of energy of electron is converted to the energy of photon. So the energy of photon is here, E photon equal to the HF. So in this case, actually photon is a X-ray. Okay, so we need, hopefully we can understand the conservation of energy, and then how the energy of the electrical potential energy experienced by the electron converted to the kinetic energy, and then converted to the photon energy when the electron hit the target atom. Okay, we continue. So from the conservation of energy, COE. So the electrical potential energy experienced by the electron is converted to the kinetic energy, half mv power of 2, and then after the electron hit the target atom or the anode, so the change to the energy of photon. So in this case, energy of photon is your X-ray. Okay, that is from the conservation of energy. Okay, so the energy of photon we can write as a E photon equal to the HF, or we can change as a Hc over the lambda. From the relationship, V is equal to the Cf. No, sorry. V C is equal to the F lambda. Okay. C is the speed of light. So when kinetic energy is maximum, when the kinetic energy is maximum, then the lambda is minimum. Lambda minimum. So when the kinetic energy is a maximum, so the lambda is a minimum, because according to this equation, lambda wavelength is inversely proportional to the kinetic energy maximum. So therefore we can write as a QV, electrical potential energy, is equal to the kinetic energy maximum, and then is equal to the E photon. So and then we can write as a QV equals to the half mv power of 2. V is a maximum, then is equal to the Hc over the lambda min. C is the speed of light, because this one is focused on photon. V is the speed, this one is focused on the speed of the electron. And then we rearrange the equation, and then we get this equation. Lambda min is equal to Hc over QV. Or we can write as a lambda min is equal to Hc over mv power of 2. Either you can write as this equation or this equation. So that means we can find the lambda min for the continuous spectrum. This one is the continuous spectrum. This one is the continuous spectrum. Here is the line spectrum. K beta, K alpha, L beta, L alpha is the line spectrum. Okay, so I just to mention here, what is the H? H is a Planck constant. C is speed of light. Q is the charge of electron. V is the potential difference across anode and cathode. Okay, so this one how we can derive the equation how to find the lambda minimum. For this until now, so hopefully you can understand the minimum wavelength of the continuous spectrum. For that, thank you.